Alright, let's give this a go. So prove that for any positive integer. So just remember, when we're proving by induction, we're only proving for our positive integers. So even though this actually works for other numbers, note that the question says prove for any positive integer. So we can do induction for this one. Alright, I'm not going to write everything down, so we would start with let, for example, P of n represent the proposition, and then we would have a look at our P of 1. So is P of 1 true? Better be, so I'm going to assume it is here. P of 1 is true. How come? Since, let's have a look. So we've got d by dx of x to the power of 1, and we know that that equals 1. So if I differentiate x with respect to x, I get 1. And then if I look on the other side, I could have written left-hand side or right-hand side, but I didn't, so I'll write and 1 times x to the 1 minus 1 is equal to 1. So it's definitely true for n equals 1. So remember, next we will assume that P of k is true for some arbitrary k, integral k, which is greater or equal to 1. So our assumption, and I won't write it all down, just the bit we need. So d by dx of x to the k, we know is going to be kx to the k minus 1. Alright, so this is what we're going to use. So what are we required to prove? And I'm going to do it over here so I have room. So we're required to prove the k plus 1 case, so proposition k plus 1, which would be d by dx of x to the k plus 1 equals k plus 1 x to the k. Sorry, this pen doesn't, I can't seem to write very well with this pen. Hope you can read that. Alright, so that's what we're required to prove, so usually we'll go left-hand side. So if we look at our left-hand side, we've got d by dx of x to the k plus 1. Alright, now remember that is the same as d by dx of, we want to use this case. So we've got x to the k times x. So we can use our product rule. So by our product rule, we would differentiate the x to the k and times by the x. So I'll put the x first. So I'm going to take the x and I'm timesing by the derivative d by dx of x to the k plus, so the other way around would take the x to the k and d by dx of, so differentiate with respect to x, the x part. So this is using the product rule. Alright, so what we can then use, of course, is back up here. We know d by dx of x to the k is kx to the k minus 1. So we've got that times kx to the k minus 1. And we know that d by dx of x, so differentiating x with respect to x, gives us 1. So we can use that as well. Alright, so we have used P of k to get to that step. Let's move us up a little bit. Okay, so so we're almost there. So remember, oh, now I can't see it. There we go, you can just see it there. So we're trying to prove this. So we need k plus 1 lots of x to the k's here. We do, if I change this a little bit, I've got k times x to the k plus x to the k. So now I can put k plus 1 outside of x to the k, which would give us our right-hand side. So remember, now we've got our P of k implying our P of k plus 1. Therefore, our P of n is true for all our integral n is greater or equal to 1 by induction.